Hi everyone, today's a Leetcode question called partition equals subset sum. So in this question, we're given a non-empty array nums containing only positive integers, and we want to find if that array can be partitioned into two subsets that have equal sum. So for example 1, when numbers equal to 1, 5, 11, 5, and C, we can partition if we pick this 1, this 5, and this 5 as one group. So give us the sign as 11. And then we'll pick another group 11, so also give us sign 11. That's why it's true. Example 2 has number equal to 1, 2, 3, 5, right? And here we cannot partition it into equal subset sum uh, because if we add up all these numbers, get 11 divided by 2, get 5.5, which is a non-positive integer. That's why we must return false. Okay, now we should a quick problem introduction. Let's think about how to solve this problem. So our intuition of this problem is to deduct the half sum of the array by a num in a specific index in backward direction. Then I want to check if the remaining value can be solved. If the remaining value can be solved, this means we add up the remaining value by the numbers we just deducted. We can successfully reach the half sum. Okay, so let me use a simple graphical explanation on this side to help you understand. So let's say we have a very simple case, nums equal to 1, 2, 3. Obviously, we can see this one can be finished, right? But how can we derive these results? Then we have to use the dynamic programming approach. So for dynamic programming approach, we have to initialize the DP array, which has the true and base cases, and all the other cases as false. And after that, in this equation, we are finding the half sum, right? So we have to calculate the half sum for this number array. So we do simple calculation. And let's say the half sum is named target, and target is 6 divided by 2, so get 3. Okay. Now let's check how to solve this problem by traversing the entire array. Well, before actually run the traversal, initialize another variables. Well, nouns is equal to a specific value in the numbers array, so initialize here, and now here is 1, right? And besides, we need a val. Okay, so the val will be starting target backward to the current noun, so val should initialize 3 here. Okay, now finish on the initialization, let's do the calculation. Well, if find DPV is false, this means we cannot finish that at the V position there to check DPV by deducting that V by N, right? So check the remaining value. And here DP3 you see is this element, right? This is false. So we have to check using this formula and set DP3 equal to DP3 minus 1. So this will give us DP2, right? And you see DP2 here is false. So DP3 is still false and no need to update at this step. Okay, now let's move this point to the previous position. Now our DP, our V is 2. Okay, then I want to redo the calculation, and DP2 equal to DP2 minus 1. So this will give us DP1. And DP1, you see this one is still false, so still no need to update at this step. So we have to move the pointer further forward to this position. And this position V is 1. So write 1 here, and change this one to 1. And change this one to 1, so this one will be 0. And you see DP is 0. Here is true, right? So this one should be true, and DP1 should be updated from false to true. It should be true. Okay, now we're traversing all the scenarios when n equal to 1, the first element. Then we have to move n to the next position. So move n to this 2. And change it to, and v should be go back all the way from target, right? So v should be set back to 3. And now let's redo the calculation. Okay, so just cross this out, change this out. Now we have to calculate again the dp3, right? And dp3 equal to dp3 minus 2 equal to dp1. But dp1 here is already true, so dp3 should be changed to true. So this one should be true. Okay, now let's move v to the previous position. So change v to 2. Now we are this one, right? And dp2 equal to dp2 minus 2, so dp0. You see dp0 is true, right? So this one should be true also. We'll change this one to true. Okay, at this step, basically we have finished our task because all element is true, right? But if you wish to do so, you can keep searching uh, by moving n to the next position. But to save time for recording, I just stop here. And the last thing we want to do is what? Is to check if the last element of this DP array is true, right? If this is true, this means we can successfully finish the task. So we just return true. Return true, and our result is done. Okay, now finish the graphical explanation. Let's dive into the coding part. So I did in previous DP version, the first thing to initialize the DP array. So DP array is equal to first true and all the rest false. And the length should be the target. So the target which is top sum should be calculated by the sum nonce divided by 2. And then I want to find the remainder for this division. So sum nonce find the remainder. And here we have to consider corner cases. So for example, the sum nonce is odd numbers and the remainder is not zero, right? If that case, we cannot find the halves subset sum, so we have to return false. So if remainder is not zero, then we have to immediately return false. Okay, now we should the initialization. Let's traverse through the numbers array and then traverse the value on the range to the target to n-1 because our Python initialization works. And since we have to check backward, we'll use this -1 here. Okay, then if dp at v is false, this means we cannot finish at the v's index position. Then I want to check the previous positions by setting dpv equal to dpv minus n. Okay, and finally return dp -1, and we are done with its coding part. Okay, let's submit the code to see it works. Okay, you see the time competitive memory usage of this solution is quite efficient, right? And I think the code is short and each one step. If you found this helpful, please like this video and subscribe to my channel. Thank you for watching and see you next time.